Assalamualaikum and hi to my lecturer, Dr. Imtiaz Ali Brohi. So today, I, Muhammad Hakim bin Muhammad NIZAM, and my number is B0324100095, and my other group mate will present about our project. So our project title is WasteWise Classifier, AI Waste Classification System. So first, we start with project overview. WasteWise Classifier is an AI-based system developed under BITI 1113, Artificial Intelligence of University Technical Malaysia Melaka. It classifies waste image into 4 categories, which is plastic, paper, organic, and glass, and provide real-time disposal recommendation to promote responsible waste management. So next is the waste management challenge. Over 50% of waste in landfills could be recycled or composed if properly sorted. Urbanization and population growth are accelerating and solid waste production worldwide. So what the waste management challenge? First is rising waste production. Rapid urbanization and population growth are driving a surge in solid waste generation. Recyclable and compostable materials are increasingly ending up in landfills due to inadequate sorting infrastructure. Second is poor sorting practices. Improper waste sorting leads to contamination of recycling stream, making valuable materials unrecoverable. Mixed waste accelerate landfill saturation and increases environmental pollution and greenhouse gas emission. So last one is lack of public awareness. Many individuals lack knowledge on how to correctly categorize waste. Without proper guidance, even well-intentioned disposal efforts result in recyclable and organic waste being sent to landfill unnecessarily. So that's all from me. I will pass this presentation to my group mate. Thank you.
Then I will explain about the project objective. So the waste classification and recommendation classify waste image into 4 key categories, which is plastic, paper, organics, and glass. So it will provide real-time disposable recommendation, which is recycle, compost, or landfill to guide user forward responsible and accurate waste management decision. User-friendly interface and accessibility, which is to simplify the waste plotting process through an intuitive graphical interface with live webcam feedback. Enable real-time classification with confidence scores, making the system accessible to users of all technical backgrounds. Education, SDG 12, and community impact. Educates users and promote responsible disposable aligned with SDG 12, which is responsible consumption and production encourage adoption by schools, communities, NGOs, and local government to drive sustainable waste practice. So next, I will explain about the target and user. WasteWise Classifier is designed for a wide range of users, from students and educators to smart city planner, all united by a commitment to responsible waste management. So the first point is student, teachers, and general public. Students and teachers use WasteWise as an interactive sustainability education tool, while the general public benefits from easy real-time guidance for everyday household waste sorting and responsible disposal. Second point is recycling staff and NGOs. Recycling facility staff and environmental NGOs can leverage the system to improve sorting accuracy, reduce contamination of recycling streams, and promote best practice in waste handling. So the third point is smart cities and environmental bodies. Local government smart cities initiative and environmental organization can integrate WasteWise to support data-driven waste management policies and community-wide sustainability goals. So next, I will explain about the system design overview. The first thing is two-phase design architecture. So the first phase, which is phase 1, offline model training using image dataset via teachable machine. And the second phase is phase 2, real-time detection using webcam feed process by the trained AI model. So the core system component, knowledge-based waste categories and disposal rules, interface interference engine, image classifier plus rule-based logic. And then it goes to the user interface, which is live webcam feed and labels display, and also the confidence score output. So that's how our system were basically working at the system core components. So that's it.
Knowledge-based detail. Waste category and classification. For core category, plastic bottle bag and containers. Next, recycle paper, cardboard, newspaper and packaging. Recycle organic like food scrap, garden waste and peel. For compost and glass, bottles, jars, containers, recycle or landfill. Each category is mapped to a disposal action via rule-based logic. For the next part, disposal rule and environmental context. Disposable rule map each waste category to the correct action. Recycle, compost, or landfill. The knowledge base also include visual future dataset for model trainings and contextual data on waste conformation, environmental impact, and proper sorting guidance aligned with SDG 12. Inference engine and operational workflow. AI classification model trains using teachable machine with Google image dataset. Rule-based logic map classification output to dispose action, recycle plastic, paper, glass, compost organic or landfill. Real-time webcam input capture live frame for continuous inference with confidence score display. For next part, 5-step workflow process. For the first one, initialize model and webcam. Second, capture and pre-process image frame. Third, perform classification inference. Fourth, interpret result, display label and confidence. Fifth, look for continuous real-time detection.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SYAKIR bin RAZAK. So now I'm going to continue for tool and technologies. So moving on to the technical architecture of the project, we divided our setup into two main areas, model training and the runtime environment. First, for our model training and dataset, we use a Google image to source a comprehensive dataset covering 4 key waste category, which is plastic, paper, organic, and glass. We then train our image classification model using Google Teachable Machine, allowing us to rapidly prototype and validate model accuracy. Second, looking at our runtime and development environment, the core system is built on Python. So we utilize TensorFlow and Keras for loading the trained model and handling real-time inference. For the actual live inference, we implemented OpenCV to handle the real-time webcam feed, alongside NumPy for efficient image pre-processing. The entire project was developed and integrated using Visual Studio Code. Next, for development scope, to ensure a focused delivery, we clearly define our project scope into in-scope and out-scope boundaries. Our in-scope features represent the core functionality available today. This includes our custom image classification model trained on those 4 distinguished streams. The system handles real-time webcam-based classification, displaying live confidence score directly to the user via a friendly graphical interface that provides immediate disposal recommendation. To maintain realistic project guardrail, several advanced capabilities were placed out of scope for this version. These include multi-object detection or bounding boxes, deployment to dedicated mobile or cloud application, complex scene handling such as poor lighting or heavy background clutter, and integration with physical IoT hardware or usage analytic dashboard. So this keeps our current deployment highly optimized for its target environment. So on the last part is benefit and impact. So finally, let's look at the real world value and impact of this solution. We span 3 major pillars. First is environmental impact. By accurately sorting waste stream right at the source, the system reduces contamination in recycling batches. This actively minimizes landfill overflow and drive a cleaner, healthier community. Second, user education and awareness. Aligning with SDG 12, responsible consumption and production, the system acts as an educational tool. By providing instant classification feedback, it teaches students and household proper actionable sorting habit. Third, convenience and real-time feedback. We engineered this for maximum ease of use. The instant webcam, feedback and clear disposal guidance make it an ideal accessible solution for school, recycling center and smart city initiative. That's all for our group. Thank you.
Hi, I'm MUHD based on NIZAM. So now for the demonstration, uh, we run the software through PyCharm. So this PyCharm. Okay, now for the testing, we need to choose the image. Okay, let's try we use plastic. So here it will identify the waste type and give the advice. So here it will say plastic for this picture. It show bottle. Okay, next let's try the next picture. It's glasses. So let's try for organic. We will say waste type organic. Okay, next let's try paper. So we say paper. Uh, okay, for the error handling, if we choose the invalid image, the output will be this. And also, if we choose the file different than image, like JPG or PNG, let's say TXT text file, same. You will say invalid image. So that's all from us. Thank you.